Chapter 5, Unit 3. We're going to talk about other relationships between a z-score, an x, which is a raw score, a mean, and a standard deviation. For a population, we're going to use the equation x is equal to mean plus z times standard deviation to solve for x, the mean, and standard deviation. For a sample, we're going to use the similar equation, x is equal to m plus zs. Here's an example. In a population with a mean of 65, a score of x equals 59 corresponds to z equals -2. What is the standard deviation for this population? Well, plug in what you know into the x equation, solve, and you get standard deviation is equal to 3 points. Well, let's make a table and let's verify our answers. So again, the mean is 65. We found a standard deviation of 3. So make your table, draw your graph. Put in your line at the score of 59, which is shown to be z equals -2. Draw your line. And now let's think about it for a minute. If two standard deviations from the score of 59 to the score of 65, which is where the mean is, correspond to a 6-point difference, then one standard deviation must equal 3 points. So it makes sense. We verified our answer. Let's look at example 2. In a sample with a standard deviation of 6, a score of x equals 33 corresponds to z equals plus 1.5. What is the mean for this sample? Well, plug in what you know. You know x, you know z, you know standard deviation. Solve the equation. You get a mean of 24. So let's make a table and let's verify. So we put the mean of 24 into our table using a standard deviation of 6. And let's plot the score that they gave us of 33, and it corresponds to z of 1.5. Does this all make sense? Yes, it does. It looks good. Example 3. In a population distribution, a score of 54 corresponds to a z-score of +2, and a score of 42 corresponds to a z-score of -1. Find the mean and standard deviation. All right, so step 1, we have to realize that one standard deviation is equal to the difference of points divided by the difference of z-scores. So x2 minus x1 over z2 minus z1. And you can look at the graph on the right and see where we plotted it. The z-scores are plotted, the x-scores are plotted right below it. So if we use the equation I gave you, plugged in 54 minus 42 over 2 minus -1, and remember if you subtract a negative that becomes a positive, we get 4 points. And then if you look at the graph again, you can see those 12 points is distributed over 3 standard deviations, and we want to know one standard deviation. So again, that's where it comes from. 12 points divided by 3 equals 4 points per standard deviation. So once we have that, then we can use the x equation to find the mean. So plug into everything we know, and you're going to choose one of the relationships to put into the equation. I used x equals 54 corresponds to 2. You could also use x equals 42 corresponds to z of -1. Either one would give you the same answer, and you would get a mean equal to 46. Here's another example, the same type. A score of 64 corresponds to a z-score of plus 0.5. Score of 72 corresponds to a z-score of plus 1.5. Find the mean and standard deviation. Again, you're going to find the difference of points divided by the difference of z-scores. So 72 minus 64 divided by 1.5 minus 0.5 gives you 8 points over one standard deviation. So the standard deviation is just 8 points. We can use x is equal to mean plus z standard deviation to find the mean. I chose one of the relationships to put into the equation, solve, and I get a mean equal to 60. And let's verify that using the table and the graph. So using the mean of 60 with a standard deviation of 8, I make my table, and I put x's and I draw lines for each of the two relationships I was given. A score of 64 corresponds to plus 0.5. Score of 72 corresponds to plus 1.5. And yes, that does make sense. The mean works for that. The standard deviation works. Everything looks good. All right, here's your learning check. Pause the video and see if you can solve. So in a population with a mean of 70, a score of 68 corresponds to negative 0.5. What is the standard deviation? Step 1, plug what you know into x equals. I found a standard deviation equal to 4. I make a table and I verify it. So a score of 68 corresponds to negative 0.5, and yep, that works. My table looks good. It's verified. Learning check 2. Pause the video. In a sample with a standard deviation of s equals 4 and a score of 64 corresponds with z equals negative 0.5, what is the mean? Plug in what you know. I found a mean equals 66. Again, I'm going to make a table and just verify it. So I put 66 in as my mean, standard deviation of 4, finish filling out my x rows, and then I put an x at the point that I was given, x equals 64, draw the line, and yes, z equals negative 0.50. It works perfectly. Learning check 3. I'm given 2 corresponding z-scores and x-scores. Asked to find the mean. Again, I do the difference of points divided by the difference of z-scores. So 35 minus 50 over negative 1 minus 2 equals 5 points difference. And then I use the x equals equation to find the mean. I chose the first relationship to put into the equation of x equals 50 corresponds to z-score of plus 2. Solve, and I found a mean of 40. Then I'm going to make a table using my mean of 40, standard deviation of 5 points, and then I'm going to put x's for the 2 scores they gave me, 50 and 35. And yes, it all looks good. We verified our answers. Learning check problem 4. See if you can solve the problem. Again, we're given 2 points that correspond with z-scores. So I use the difference of points divided by the difference of z-scores, and I found a standard deviation equal to 5 points. I use the x equals equation. The point I used was x equals 65 corresponds to a z-score of plus 1. Put it in. I get a mean equal to 60. Verify with my table and graph. It all looks good. We're done.